Alright, so now we're back, and so now we're just going to breeze through two of our goals. So first, the properties of limits, and then we're going to go into continuity. So first, for the property of limits, there's actually 5 of them. It's the scalar multiple, sum or difference, product, quotient, and power. Basically, what this means is if the function f of x, the limit as x approaches to c of f of x does exist. So if if it does exist for f of x and it also exists for g of x, then all of these do apply. But if the limit as x approaches to c of f of x does not exist, so if it includes those three, remember, if it oscillates, if it increases or decreases without bound, or if they approach different values, then any of these don't apply, then it would not work. So first of all, I'm just going to go through them, and I'm just going to tell you it. So the scalar multiple is basically saying that if f of x, again remember, the limit does exist for f of x and of g of x. So the limit as b, which is any number, is multiplied by the limit of f of x, then the limit of that is equal to b times l. Basically, what that just says in simpler terms, like say the limit of f of x. I'm just going to give it values so it's not so complicated with so many variables. So the limit of f of x, like say l is 4. Okay? So let's just say here is just a straight line f of 4. So here the limit as x approaches c is 4. So that's just saying, and let's say b is 3. So that's just saying the limit as x approaches c of 3 times f of x is equal to 3 times 4, which will equal eventually 12. So you can just multiply them out and it's perfectly fine. Here, sum or difference, basically all these are the same thing. It's just saying that the limit of x as x approaches c of f of x plus g of x is equal to their limits combined. So again, I'm going to give k the value of 3. So here f of x plus g of x, and that limit is equal to 4 plus 3, which is equal to 7. That's for the sum. Or the difference, you could do 4 minus 3 is equal to 1, and that would work out. Again, remember, this is just if the limit of f of x does exist and the limit of g of x does exist. It has to for these to work out. If not, you're going to mess up. Product is just saying the same thing. F of x times g of x, you can multiply their limits and you can find the limit of f of x times g of x. The quotient rule, if you divide the limit of f of x over the limit of g of x, is the same thing as finding the limit of f of x over g of x. But the important thing is, the limit of the denominator cannot equal to 0. Remember that something divided by 0 does not work. It just doesn't figure it out. Power is basically, again, same thing. The limit of f of x over n is the same thing as the limit of f of x to the power of n. So that's property limits. I actually think this is very basic. It's just what you have to remember, for me, is just 2 things. The limits have to exist, and I know I'm repeating that again, but it's very important. And for the quotient rule, the denominator cannot equal 0. So now we're going to move on to our next topic, which is continuity. It's basically just saying if a function is continuous in between 2 values, right? So here I'm going to show you the 3 forms in which it's not continuous. So over here, f of x is not defined at c. So here you can see a graph. It's in between the values of a and b. And the value of as x is equal to z of c is not defined. There's an open circle right there. So that means it's not continuous, right? The next one is the limit of f of x does not exist at c. Remember, that's basically our ones that I was explaining over here, that they approach different values from the left or right. Here you can see over here it's approaching a different value. I'm going to give this one a value of 6. And this one is approaching a different value, a value of 3. So it does not exist, right? So it means it's not continuous. Finally, here it's saying it's also not continuous is the limit of f of x does exist, but it does not equal f of c. So here you can see the limit does exist because it does approach the same value from left and right, does not oscillate, does not increase, increasing or decreasing without bound. So that's good. But f of c is like say 2, and the limit of f of x as it approaches c is 4, and that can't work out. They have to be the same number. But here, since they're different numbers, it's not continuous. And of these 3, 2 of them are removable and 1 of them is not removable. What I mean by that is if I just change 1 point, I can make this continuous. But non-removal means I have to change the whole function. I can't just change 1 point. So, for example, the first one, f of x is not defined at c. What I can just do is I can just plug here this point and we're good. It's continuous. So there's no break in between a and b. For the third one, which is also removable, is because they're different values, as limit as x approaches c and of f of c, what I can do is I can just cancel out this c of f of c and I can just plug it in over here. I'm just changing 1 point, right? And that just makes it continuous. But for here, which is the limit of f of x does not exist because they approach different values, I would have to change the whole function to make it actually approach the same value. And that's not removable because you're going to have to change the whole function. It's just a completely different problem. And to make it actually continuous, so the function between the closed interval a and b, so here I'm just going to draw it for you. So here we have our x and y, this is a and this is b. So our function in between this closed interval, and the limit as f of x as x approaches a from the right is equal to f of a, right? So here we have an open circle. And the same thing over here, the limit as x approaches b from the left of f of x is f of b. So over here, f of b. And in this closed interval, that is continuous. If there's any of these 3, then that means it's not continuous. And then you would have to see if it's removable or not removable, and if you could change it or not. But basically what you need to know is you need to know these 3, and you need to know which one's removable and which one's not removable. And that's about it. So now we're going to move on to our final topic, and I'll see you over there.